Hello, statistics class. This is Miss Ellis in a video, even though I'm not there. It's kind of like I really am there. Here is the key to the binomial geometric of Poisson worksheet. This is kind of how your test is going to be. They're not going to tell you what type of distribution there are. You have to figure that out on your own, and then obviously complete the actual math. So on problem number 1, the farmer is worried about a drought. The farmer's almanac records an average. That is your clue. 7 days of rain throughout the month of May. He knows if he doesn't get more than 3 days of rain, his seed will not germinate, which means his crop will not grow. So the average, the only type of distribution that uses average is Poisson. So that is how parts A, B, and C are filled out. Now, Poisson, what is the probability that he will get exactly 4 days of rain? Exactly, that's why we're going PDF. You have your average, and then we're doing exactly 4. That comes out to be 0.091. Part B, what is the probability that his crops will germinate? Well, that comes from the story problem. They will germinate if you get 4 or more. Or more is a tricky guy. You got to do 1 minus the CDF version. If it's 4 or more, you're going to go 3 or less. That gives you 0.918. And part C, what is the probability that he will receive 7 days of rain or less? That is 7 or fewer. Average is 7. We're going X of 7. And or fewer, that is why we're choosing CDF. You get 0.599. On problem number 2, the FAA keeps track of the percent of on-time flights for each airline. Recently, U.S. Airways was on time for 78% of its flights, so we're getting a little successes here. And we know we are going to take exactly 6 flights. That exactly 6 flights, that's giving me a number of trials. I stopped at 6, which is why I'm leaning towards the binomial here. I have a probability of success and an N. I jotted them over here on the right-hand side. So when they say form a probability distribution, if there are 6 flights, you can go anywhere from 0 all the way up to 6. The probabilities will all be filled out with PDF. Binomial PDF, tables are always PDF. You go N, then P, then you fill them in with all your X's there. So 0, your probability of success is 0.000. 1 is 0.002, 0.021, 0.101, 0.269, 0.381, 0.225. Then you can kind of use that or set up probabilities on your own here. Part B, what is the probability of exactly 3 flights? Well, if you set it up, exactly is PDF, N is 6, P is 0.78, we're doing exactly 3, which is 0.101. It also matches with the 0.101 that is in your distribution. Part C, what is the probability that 5 or more flights will be on time or more? Again, the trick is 1 minus the CDF of 4 or less. 5 or more, other end is 4 or less. That gets you 0.606. D, what is the probability that there will be less than half of the flights on time? Well, half of 6 is 3, and then we're looking at less than 3. So the 3 is not included, which is why I'm throwing 2 in the back end with my CDF. You get 0.024. E, how many flights should the sales manager expect to be on time? This is an average, or in other words, the mean of a binomial, which is N times P. Do not forget the special mean, variance, and standard deviation here. So 6N times 0.78P, you get 4.68. That is the actual answer. That should be written down somewhere. Then if you feel like averaging it, go ahead and kind of round it up and say, oh, around 5. But I still want the actual decimal on the test. Number 3, the McDonald's Monopoly game is designed to have 1 winner for every 4 players. So probability of winning over here on the right, P, 1 out of 4 winners, is 0.25. That's it. That's all you're given is a probability of success. And really, with Monopoly, you can play and play and play and play. You know, you can go once a week, you can go 5 times a week, you can go 50 million times a week. if you really love McDonald's Monopoly, it's open-ended, which is why this is a geometric distribution. Part A, what is the probability that you will win on your first try? That's exactly one try. So PDF, success is 0.25, our X value is 1. So 0.25 is your probability. Part B, what is the probability that you will not win until your 6th purchase? Okay, so it's kind of, you could win 6 or really just on the 6th one. So we're going PDF, and then 6 is our first win, so 0.059. C, what is the probability that you will win by your 6th? That's a little different. Well, you could win on the 6th, or the 5th, or the 4th, or the 3rd. Everything kind of, it's 6 or fewer. So CDF, we switch to CDF with the 6, and you get 0.822. D, what is the probability that you will not win in your first 4 purchases? That means it's probably happening in 5 or more. So you can do 1 minus the geometric CDF of 4 or less, which gets you 0.316. The alternative is if you are not winning in your first 4, you're losing, which your probability of failure over here on the left is 0.75. You're losing those 4 games. It'll also get you 0.316. E wants a probability distribution for the first 6 purchases. So we've got 1 all the way through 6 here. You're going to do geometric PDF. Tables are always PDF. To fill it all out, you get 0.250, 0.188, 0.141, 0.105, 0.079, and 0.059. On the back, next problem. As the production manager, you know that the automated packaging machine defectively wraps a product 3 out of 76 times. So they're giving you kind of a defect success right here. Your boss believes there should never be a defect. As he stops by to see how things are going, you invite him to see the finished product coming off the assembly line. He agrees but says, well, you only have time to see 15 products. What is the probability that he will see a defect? Well, this one here is also geometric. We are given just a success rate, and if it's an assembly line, you really are going for forever. So that puts it into the geometric kind of definition. Your defect rate, that 3 out of 76, ends up being 0.0395. Now, if I'm doing 15 products and we want to see if we see a defect, it's that 15 or anything in front of it, which is why I'm going with CDF, and you get 0.4537 as the probability of that happening. Problem number 5, let me get myself lined up here. 18% of all people passing the Salvation Army bell ringer will actually donate, so we've got a probability of success. During 1 hour, 76 people pass by. They're giving me a sample size or a number of trials, N. With those 2 parts, N and P, I know that this has to be a binomial distribution. They want to know how many people will likely donate. How many is average. So N times P, you get 13 point, there's a point in there, 68. Again, I would like the decimal. If you feel like you want to estimate it up or down to about 14 people, you can do that as well. But make sure I'm getting the decimal as well. I need to see your work. Part B, using standard deviation, find the range of the number of donors that lie within 1 standard deviation. So I've got my mean from Part A. I have to find my standard deviation, which is the square root of NPQ. That gives me a standard deviation of 3.35. If I'm going to go plus or minus 1 standard deviation each direction, I have to use my little formula here. Mean plus 1 standard deviation minus 1 standard deviation gets me a range between 10.33 and 17.03. C wants the range if you use 2 standard deviations. Again, you've already found the mean and standard deviation. Don't do that all over again. Just do plus 2 or minus 2 standard deviations. Now your range is between 6.98 to 20.38. Do try to put the range in order from smallest to largest. Now number 6, this was a kind of toughie. Okay, this is kind of the challenge question. A bank finds that it averages 14 customers in the door every 15 minutes. Okay, right away, the word average is in there. You know it has to be Passan. All right. In the interest of customer service, we're trying to keep no one waiting in line. The manager knows she needs one teller for every 3 customers. How many tellers must she have working if she wants to avoid a wait for all 95% of customers? Okay, so 95%, that is our goal. This one you actually have to work backwards. We know it's going to be Passan and CDF. We know that our mean is 14, and we know our goal is 95%. That's a probability. So you have to kind of guess and check to find the X value that actually works. Now this does take a while. Eventually you will stumble upon the fact that 20 is the one that actually works here to give you a probability of 0.95. So we're looking at 20 customers. If you divide that by 3 tellers, you get 6.67. So about 7 tellers are necessary. Again, this isn't necessarily one that we have done in class. Again, this is more of a challenge applying that knowledge of Passan to kind of different scenarios. Now, your test is tomorrow. It is 100 points. Study this review. Study the review from Tuesday. Study your notes. Study your worksheets. You've got reviews. You have a quiz. All available resources. Please study appropriately. Even though I am not there, does not mean you do not have the capabilities or resources to do well. Please study. I want good scores.